I'll try to do a series of ellipse type questions. Model what you see in your homework. Here it asks you to actually find an equation for an ellipse first, knowing that the vertices of an ellipse are positive negative 4, 0, and the foci are at positive negative 2, 0. So this kind of tells us how this thing needs to be set up in regards to its orientation. Says we've got vertices at plus or minus 4. So 1, 2, 3, 4. So there's one vertex of my major axes, and there's another one. Now, the way I knew that was the major axes is because they tell me where my foci are located as well. And my foci are located at positive 2 and negative 2, 0. And that tells me then the foci are always on the major axis. Okay, something to, it's a fact that we should know. Okay, so now I've got to figure out, how does this ellipse look? I've got kind of the rough sketch right now, kind of going through there. It'll come past through there, but I don't know how high on the y-axis this thing's going to go through. So we should have the general format for being able to do this. Now, if you remember, every ellipse is going to be of this form: x squared over a squared plus y squared over b squared equals 1. Now, again, I don't care whether it's a or b here. It really doesn't matter too much to me. What I'm worried about, what I need to know, is that where does this length of 4 go inside my equation? Okay, this point here is at 4, 0. And if you remember from an example we did in class, the way we get that 4 is that we take the square root of that number. Okay, so if we take the square root of that number and got 4, that number had to have been 16. And I know that that is going with the x because it's in the x direction. Okay, if the 4 would have been up like this direction, then the 16 would go with the y. But I know it's in the x direction, so it's got to be attached to it's got to be the denominator of my x's. So that's 4, so that denominator becomes 16. So I've got x squared over 16 plus now y squared over b squared. Still, I don't know what b is, and that's the issue at hand. The way I'm going to find b is I'm going to remember we have a formula that helps us find our focus. Our focus length, which says c squared, is equal to a squared minus b squared, where that is the bigger of the denominators. That's going to provide us the length of our focus. Okay, well, our focus length right now is that distance of 2. Okay, so c squared would be 4. Okay, a squared, well, that's the bigger of these two, and it's the denominator comes from the major axis, so that's 16 minus then b squared. Well, now when I subtract 16 from both sides, I get negative 12 is equal to the opposite of b squared. So b squared is going to be 12. So now I put 12 there, and that then becomes my equation for that ellipse. Now, if I wanted to, I can now take the square root of 12, which root 12, real quick here, is 3.46. So I'd go 1, 2, 3.46, and then 1, 2, 3, 3.46, that direction. So now I've got those points to help me finish off that ellipse. I'll just kind of quickly go through these on the last slide of this PowerPoint. It just says find the vertices, foci, major, minor axes, and graph each ellipse. I'm just going to kind of write down the critical information here to do these. I don't know if I'll necessarily graph each one of them. But looking at this one here, we know it's ellipse. We got the plus and we got the 1 over here, so we know it's ellipse. Now, if I wanted to graph this, I'm going to have to take the square root of the 25, and I get 5. Okay, so I get 5 there. Take the square root of that, I get 3. So the x is paired with the 25, so on the x-axis I need to be paired with a length of 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Remember, the root of our denominators is going to tell us the length we need to move in both directions from 0, 0 to create our endpoints of our major and minor axes. And now this one I'm going to go out. So square root of 25 is 5, so I go out 5 units in both directions. All right, so I've got my mouse is having problems. There we go. All right, so you're about 5 units that direction, and 5 units in that direction. All right, now I'll take the square root of 9, okay, and that's paired with the y. Okay, so the 3 that I get when I take the square root of 9 is going to tell me the distance I go in my y direction. So give me a second, I want to try to fix my mouse. Okay, I think that makes it better. Maybe. All right, so we take the square root then of the 9, and we're going to go 3 units up in the y direction. So, okay, hopefully this will let me get through this. Then I'll have to turn my computer off and restart. All right, so getting back to the square root of that 9, we got 3, so we move up 3 units in that direction. So that tells me that point there and that point there. So those are the endpoints of my major axes and my minor axis. Now remember, the x, or the horizontal axis, is the major one because that number there is bigger than 9. Now if you want to find the foci, all you got to do is you take the formula c squared is equal to, now you're going to subtract these two things, but you want to do it so that the difference that you get is positive. So we're going to go, in this case, 25 minus 9. So we get 16. So c is going to then equal plus or minus 4. So now foci are always on the major axis. So I'm going to go over 1, 2, 3, 4 units on the major axis, put a point there. 4 units on the major axis that direction, put a point there. And that's a focus. That's a focus. We've got these endpoints that we can draw a smooth curve through and provide us our ellipse. Let's try this one here. Okay, so this one's going to be a little bit different because of how our axes are set up. Okay, now let's actually do it this way. If we look at the denominator with the x's, that gives me square root of 9 is 3, so I'm going to move over 3 units on the x-axis. 1, 2, 3, 1, 2, 3. So there's endpoint there and an endpoint there. Now I'm going to look at the square root of that number, it gives me 8, and that's paired with y. So I'm going to go 8 units in the y direction. So 1, 2, 3, 4, 5, 6, 7, 8. So there's an endpoint of that axis. 1, 2, 3, 4, 5, 6, 7, 8. Endpoint there. And now you've got essentially the components that you need to create that ellipse. Okay. It also wants the foci, or foci, however you say it. So again, that's going to be c squared is equal to a squared minus b squared. Now I don't care like I said, which one's A and B in this case. We want this number here to be bigger, because we're going to have a distance that's positive. So we're going to go 64, then minus 9. And then that provides me with C being the square root. 64 minus 9 gives me 55, so square root of 55. And square root of 55, let's just do that real quick. It'll be a little bit bigger than 7. 55 square root 7.4. So I'd go up here, that's 7.4, maybe be right there, and then 7.4 down there. So those are my two foci. Pretty straightforward, I think, on how you do these. This last one here on the right, a little bit different because of the original setup, but this is kind of like the one we did in class. The first thing you're going to do is divide everything by that number over here. So I'm going to get 4x squared over 16 plus then y squared over 16 equals 1. Well, that reduces to x squared over 4 plus y squared over 16 is equal to 1. Now, with the x, I have this 4, so I take the square root of 4, it gives me 2. So in the x direction, I'm going to move over 2 units. And there's going to be my endpoints. And now this number is square root of 16 is 4, so I'll move up 1, 2, 3, 4. Like that. 1, 2, 3, 4 gives me that. Okay, so those are my endpoints and my, a lot of times called the vertices of your major and minor axes. Call them endpoints, same thing. But then we want to find the foci, so c squared is equal to a squared minus b squared. So in this case, it's going to be 16 minus 4. So again, c is going to be equal to root 12. Similar to one we've already done, I believe, with the c. Never mind. I think there was one earlier that we ended up with root 12, or 12 as one of these numbers. So forget what I just said there. So root 12 is 3.87, so 3.87 maybe about right there. 3.87 about right there. We had to ballpark those. But that gives us the criteria then that we can use a smooth curve to go through those black vertices. Pretty much every question is like that, pretty straightforward. If I ever want to move an ellipse, okay, I just kind of show you this with GeoGebra real quick. Let's say we use that. We'll just go ahead and use this ellipse here, x squared over 9 plus y squared over 64. So x squared over 9 plus y squared over 64 equals 1. Okay, so we get that. But let's say I want to move it away from 0, 0, because right now our center is located at 0, 0. Let's say we want to move it away from there. Let's say I want to put it at 4, 1, 4 comma 1. So if I want to move something in the x direction, that has to be done to the x coordinate. Okay, so the x variable, and I want to move it to the right. Okay, if you remember anything we've done with transformations, that means that you're going to subtract the distance that you want to move it. So I want to make my numerator here with the x squared as x minus 4 squared, and that should move it to the right 4 units. So let's hit enter and see if it did that. It moved it to the right 4 units. Now I want to move it up 1 unit, because right now my center is right here at 4, 0. So let's move that up 1 unit. So if I want to move up 1 unit, okay, with regards to the y, it's going to be minus that 1, and then hit enter, and it moved it up 1 unit. Okay, so that would be the equation of an ellipse. Now, I don't like the format this is showing it in. Let's see if it'll. We're going to put it in this format. So you might see, if you might remember from last year when you did some questions like this. Now, a lot of times in the questions you got last year, these were a lot nicer numbers than this. But they asked you, can you manipulate this to create the ellipse format, the standard format that we use, where this is a 1 over here. Can you manipulate this to see where the center is and graph this thing? And the way you would do that is you complete the square, basically. on the x's and y's. And it will transform that thing into essentially x minus 4, that quantity squared. I believe it was then over, well, yeah, we wanted it over 16, and then plus y minus 1 squared over 9. I think that's what we had originally. Let's go back. 9 and 64, sorry. That's a 9, and this was a 64. So those are just coming straight from what we started with. Equals 1. So what we started with, I should write that down, x squared plus 9, or x squared over 9 plus y squared over 64 is equal to 1. That is the original that we started with. But if I want to move it away from 0, 0, move it to the right, you subtract from the x. Move it up, you subtract from the y. If I wanted to move it left, I would add, and if I wanted to move it down, I would add as well to the y's and x's. And that's consistent to the transformations that we used with circles, if you remember back that far. Hopefully this helps. I'm going to real quick search through WebAssign, see if there's any other kind of different types of questions that might cause you issues, but I think that should be enough examples to allow you to push through those questions on WebAssign.